Good afternoon, students, and this is lesson 2-4, the third recording for today, but the second lesson. And let's go ahead and get started. Okay, now I should be sharing with you. Okay, let me try to make this so it's easy to see. I'm trying to remove any shadows or anything like that. Okay, hope that's okay. This is lesson 2-4 in your book. It's on page 110, solving variables on both sides. Solving with variables on both sides. So here's the rules, okay? Rule 1, the first step would be to move all variables to the same side by addition or subtraction of the entire term. Now, what I mean by that is normally when you see a term, like let's take for example, 2x is equal to 10. Normally, what I would do is I would divide 2x by 2 in order to isolate the x. But in a case like this, I'm saying literally subtract the entire term 2x. Okay, now when I say subtract it, I mean subtract it from both sides. So I'm not multiplying, I'm literally moving the entire term by opposite operation. Okay, so you see on this side I have positive 2x, and I subtracted here, I now have 0 on this side. On the other side, I have negative 2x because I subtracted it, or minus 2x. You could say it either way. Okay, let's continue with the steps. So step 2 is to simplify the expression on both sides of equals. Now we simplify as we learned in lesson 2-3, like terms, distribute or using the distributive property. When I said etc., I mean things like maybe like removing of fractions or decimals if necessary. By the way, you don't always have to remove a fraction or decimal in an algebra problem. It just makes it a lot simpler to do unless you're really good with the rules of decimals and fractions. Okay? All right, so continuing on, let's go to step 3, IOB, which again is, yep, you're right, Hector, it's isolate opposite both for addition and subtraction. Remember, we want to do addition and subtraction first with equations. And then step 4 is IOB, isolate opposite both for multiplication and division. Okay? And then at that point, you should be done with the problem and have a value for your variable. Now, the most common variable we use is x, so I'm going to stick with that unless I'm given a good reason not to. I have some problems here for you. These are problems directly out of the book, so if you want to look at them again after this video, of course you can watch this video again, but you can go to the book. All right, so I have 5x plus 2 is equal to 2x plus 14. Okay, now my variables are 5x and 2x. My constant terms are positive 2 and positive 14. Now, one thing I didn't say in the rules up here, and I think I'm going to go ahead and add this. For step 1, you want to move all constants to the other side. Now, constants are just numbers. In my mind, because I've done this a few times, it was kind of obvious, but I just want to make sure that it's not obvious because you probably don't do this all the time. So I want 5x and 2x on the same side. So what I'm going to do is I'm going to subtract 2x from the right side of my problem, and you always have to do it to both sides. Okay. So 5x minus 2x is what? Aaliyah, you're right, it's 3x. Okay, now I want 2 on the opposite side, so I'm going to subtract 2 from this side, leaving me with 0. And I'll subtract 2 from the other side. What's 14 minus 2? Jerry, you're right. 14 minus 2 is 12. Actually, I'll use the blue pen for that part. Okay, so now let's see what I have left. This became 0. This became 0. 5x minus 2x becomes 3x. 14 minus 2 becomes 12. So bring down my equals sign, and I have 3x is equal to 12. Now, just to make it neater, I'm going to write this closer. Okay, now the second step, simplify. Well, there's nothing left to simplify. I already did it when I moved everything so that I have the x's on the other side. Well, actually, I did the work here because technically I could rewrite this problem once I've moved everything like this. I can say 5x minus 2x is equal to 14 minus 2. Okay, so in that case, yeah, I would still need to do the simplifying. But what I had done is when I moved everything over, I moved it to the spots where I can do the simplifying without actually writing it linear style, or basically meaning from left to right. Okay, so now jumping back to where we're at, it's at 3x is equal to 12. Sorry, I probably should have written it this way down here, but hopefully you'll still get it. So then the next step is IOP for plus and minus. I don't see any plus and minus other than what I've already done and complete it, and then IOP for times and divide. So in this case, I have multiplication, so I must divide to unmultiply. 3 divided by 3 is 1. 1 times x is x. 12 divided by 3 is 4. So there's my solution. X equals 4. Okay. Hopefully that was really clear. Okay, let's go to the next problem. I'll leave this one where you can see it, just so you don't have to keep pausing and stopping and stuff. All right, so in this problem, this is a special type of a problem where um, it's called an identity problem. I know that the word identity problem can mean a lot of things, but putting political issues aside, let me just go ahead and say what I mean for this problem. This is like an identity property problem, and you'll see as I begin to do it. So first, I have parentheses here, and I don't have parentheses on this side. So in order to move 5x over to this side, I have to get rid of the parentheses. How do you get rid of parentheses? Evelyn, you're right. You need to use distributive property. So let's distribute the 2. 2 times 5x is 10x. Now remember, when you see a number coefficient, meaning a number next to a variable, and a variable, you just multiply the numbers, but then they're still attached to the same variable. Okay? Now we have 2 times 6, which is 12. Okay? So now I've distributed the problem. Okay, so now if we follow the steps from the first problem, let me show you what's going to happen. Okay, but first I want to point something out. Do you notice that 10x plus 12 looks just like 10x plus 12? It's like the identity property. They're the same on both sides. Okay, but let's follow the steps and see what happens. So if I subtract 10x from both sides, then I would get 10x minus 10x plus 12 is equal to 12. Okay, and if I subtract 12 from both sides, then I would get 10x minus 10x is equal to 12 minus 12. Okay, well, let's see. 10x minus 10x is 0, and 12 minus 12 is 0. So I have 0 equals 0. Now, the point I'm trying to make is with this particular problem, I'm going to just draw a line here so we don't get it mixed up with my last problem. Okay. When we got to this point and you had the same number on the same sides, now when I say the same number, given that we don't know the value of x, this is called an identity property problem, because whatever value I give x, it's going to equal the same on both sides. So let's just say, for example, that x was 1. I would go 10 times 1 is 10 plus 12, which is 22. 10 times 1 is 10 plus 12 is 22. Then my answer would be 22 equals 22. Let's just say that x was 0. Then 10 times 0 would be 0. 10 times 0 would be 0. Then the answer would be 12 equals 12. Okay? You see what I mean? Whatever value I put in for x, it's going to make a true statement, but at this point, both sides are already equal, so I don't have to simplify it any more than this step right here. Okay? Because it's identity numbers, so no matter what value I put for x, it's always going to be true. Why? Because the expression on the left, which basically just represents one number, it's just in pieces, 10 and x and 12, is the same as what's on the right, 10 and x and 12. Okay? So if all of your numbers, all of your symbols, and all of your variables are all the same on both sides, then you can stop the problem, and it's an identity problem. Now, remember, with an equation, we're trying to find a true statement. But sometimes equations don't give you a true statement. So let's see what happens with this one. And this problem, again, is in the book. I think it's on page 112, I believe, or maybe 113, somewhere around there. Anyways, the problem is 9m minus 4 is equal to negative 3m plus 5 plus 12. So the first thing I want to do is I want to identify my variables. And according to the first steps of the lesson, I want to move all my variables to the same side. So 3 is negative, so I'm going to add 3m. Now remember, I'm not multiplying or dividing yet. I have to get all my variables together and combine like terms before I can divide to get rid of the coefficient. And the coefficient is the number attached to the variable. Okay? So I'm adding the whole term here to get rid of the negative one. Negative 3m plus 3m is equal to 0. So I have 9m plus 3m. Now I'm going to write this linear style. So I'll have 9m plus 3m minus 4 equals 5 plus 12. Now you notice since I moved the 3m to the other side, I don't have to write it here again. Okay? Because for this side, it's canceled out. Okay? This one, I didn't solve it yet. I just rewrote it. Now, I want to get my other like terms onto the same side. So I have negative 4 here, or minus 4. So I have to add 4 back in order to eliminate it from this side. Minus 4 plus 4 is 0. Now I have to do the same to the other side. Okay. So now I'm just going to rewrite everything over on this side so it's cleaner. 9m plus 3m is equal to 5 plus 12 plus 4. Okay, now let's go ahead and simplify. 9m plus 3m is, let's see, who have I not mentioned in a while? Jerry, I think you're right. That is 12m. Okay, 5 plus 12 plus 4. Okay. Isai, what do you think? All right, yeah, I agree with you. 5 and 4 is 9. 9 plus 12 is 21. Okay. So now I have 12m is equal to 21. Okay. So in this case, what I'm going to do is I'm going to divide both sides by 12. And I have m is equal to 21 twelfths. Okay. Now, that gives me a fractional solution, which is not always the best, but at least it's a solution. Okay. Hold on just a second. I'm going to pause. Okay, I just made one more problem for you, so let's go ahead and I'll share my screen so you can get that one. All right, so this problem is 2x plus 7 equals -1 times 3 minus 2x. Now, the last problem, I think I said a little thing about, well, what if a problem is not true? And that problem ended up being true, but let's take a look at this problem and see what happens. So first thing, I want to move -2x over to the other side, but I can't do it because it's in parentheses, so I need to distribute. So -1 times 3 is, yep, you're right, Isai, that would be -3. -1 times -2x, yep, Hector, you're right, that would be +2x. Because the negative here cancels the negative there. I'll go ahead and rewrite the rest of the problem so that it's easy to see. Now, what I want to do is I want to move 2x over to the other side. Now remember, I can't stress this enough, when I have a variable on both sides, I don't divide to get the variable isolated. What I have to do is I have to subtract or add the entire term, meaning the number and the variable together. So I'm going to subtract 2x from both sides of my problem. 2x minus 2x equals 0. So I go over here and subtract it. 2x minus 2x equals 0. So let's bring down everything that we have left. We have the equal sign, we have the 7, and we have -3. Now, it looks like by subtraction, the variable has been completely eliminated out of the problem. So I ask you the question, does 7 equal -3? Aaliyah, you're correct. So are you, Evelyn. And Jerry, yep, you're right too as well. 7 does not equal -3. So some occasions you might get an equation that's not actually an equation. Basically what I mean is whatever's on the left side is not equal to what's on the right side because the answer ends up being false. Now you don't want to assume this until all the variables have either been solved for or eliminated. Okay, so in this case, the variable has been eliminated because when I subtracted 2x from both sides, then it completely got rid of the variable altogether. Since what was left was not equal, then we know that this is not an equation. So you would say no solution, okay? Which is just sort of a mathematic way of saying this is not a real equation. Now the math book says that it's an equation that is false, okay? So that's kind of a fancy way of saying it's just not an equation because the word equation means that it is equal. And to say that an equation is false is saying, here's something that's equal that's not equal. So I think it's kind of a waste of time to say it that way. But either way, the answer would be a no solution. Thank you very much, and I hope you enjoy this video.